All right, we're going to take a look at equations that are in slope-intercept form. So a slope-intercept equation. And a slope-intercept equation is y equals mx plus b. So let's make that a little bit bigger. M is the slope, and b is the y-intercept. So it's the place on the coordinate plane where your line crosses the y-axis. So it would be this point. And that point is always in the form of 0 for x because we're not moving left or right. And we're either going up or down on the y-axis, so whatever that value is, and we call it b. So if we're going to take some basic equations, y equals negative 2x plus 7, and we want to identify the slope and the y-intercept just to get started and be familiar, we just take the information and we line it up to y equals mx plus b. All right, that's our slope-intercept equation. So y is y, equals is equal, and what you can see is in the place of m, which is our slope, is a negative 2. Now, because negative 2 is an integer, we're going to put it over 1 because slope, as we remember, is always called a rise over a run, or what we say is the change in y, so delta y, over delta x, which is our change in x. So subtract the y's over subtract the x's. So when we're getting it out of the equation, if it doesn't have a denominator, we put it over 1 so that we have a run. Now what you can see is there's always a plus sign, all right? And then b is the value that you find in the last position. So in this case, because it's plus 7, it's a positive 7, so we'll just write 7. In the next problem, y equals 2/3 x minus 4. Well, in the y equals mx plus b, we line it up. We have y, we have equals, and then in the m position, we have 2 over 3, which is 2/3. So our rise is 2 and our run is 3, and both positive. And then we have plus b, but in this case, we have a minus 4. So our b value is a negative 4. So negative 4 is where on the y-axis that our line will cross. All right, our next equation is y equals x over 3 plus 5. So I'm going to write that a little larger down here. Now we need a coefficient in front of our x, so it's 1. So what we're going to do is we're going to separate out our slope, 1/3 x plus 5. So this would be our slope. So whenever you don't see a number, a coefficient for x in the numerator, then you would write 1, okay? So when we have a fraction, we'll pull that apart to the side there, and we have a slope of 1/3. So when we're doing y equals mx plus b, we have 1/3 for our slope. So we're rising 1, and we are running 3. And our y-intercept is plus 5, so b is 5. All right, in the case where we have y equals negative x over 5, again, I'll make that a little larger down here. The coefficient of x is 1. So we're going to separate it into a fraction times x. But as you notice, there's nothing added or subtracted afterwards over here. So it's really like a plus 0. There's nothing there. So 0 would be the number, but we never write anything with a plus or a minus 0. So if you want to do that here, you can. You can just put it on here for yourself. Put that 1 in front, that negative 1 in front there because it was a negative x. And so when we pull off our slope is going to be negative 1/5, and our y-intercept is going to be 0. All right, in this case, the next one is y equals negative 7x. Again, we don't have anything added or subtracted after the mx term, so it's y equals mx plus b. We have all the way up to here, right up to there, but we don't have anything after, so we just put plus 0 so we can see it. All right, it won't be typed that way, but you can definitely write it that way for yourselves to see it. Our slope is negative 7, so negative 7 over 1 is fine. Gives you a rise and a run. And our slope, our y-intercept, is 0. Okay, we should make that one. Okay. So that's how you extract the slope and the y-intercept from a given equation in slope-intercept form. All right, now, how do we write an equation given those two pieces of information? Well, if we want to write an equation of a line that has a slope of -5 and a y-intercept of 3, we have to remember a couple of things. One, we want to write it in slope-intercept form, so we're going to write that y equals mx plus b. And now what we have to do is off to the side is just to identify our slope and our y-intercept. Our slope is -5. Our y-intercept, which is the b value, is 3, and it's +3. So we'll write a plus sign or a positive sign there so we can see it. And now we literally plug in. The only thing that is never ever affected is the x and the y. They're always going to be in the equation. So y will always appear, equals will always appear. We will now substitute in a -5 for the slope. The x will always appear. And then we're going to substitute in the b, and it's +3. And that is our equation written in slope-intercept form from a simple word problem where they give us the slope and they give us the y-intercept. All right, let's take a look at how can we write an equation from a graph. All right, well, remember, you always have arrows on your graphs, okay? So we're looking here, and now we've got to figure out the slope and the y-intercept. Well, the y-intercept is the easiest to grab. You follow your line all the way until it crosses the y-axis. Now, this is our x-axis, and this is our y-axis. So we follow our line all the way till it crosses the y-axis, and we see it crosses right here at 4. So our y-intercept, which is the b value, is 4, and it's positive, so we're going to put a positive sign in front of it. If it were down here, it would be negative. All right, now what we have to do is find our slope, okay? All right, so here we go. Now, what we want to do is identify another point that crosses a grid, okay, these little grid lines. So none of these cross a grid line until we get right here. So what I'm going to do is I'm going to walk from my pink point all the way up to my red point. So I'm going to go up 1, 2, 3, positive direction because we went upwards. And then I'm going to walk to the left 1, 2, which is a negative direction, so it's -2. So my slope is 3 over -2, or what we typically do is we just throw the negative sign in the numerator and we keep the denominator. Okay, so we just write it as -3 over 2. Another way you could look at it is this. Let's walk from our red point to our pink point. If we were to walk from red, we'd go 1, 2, 3 down, making it -3. But we'd go 1, 2 to the right, and that would be +2. So -3 over +2. That's why these are the same. So now we need our slope-intercept equation. Remember, our slope-intercept equation is y equals mx plus b. So we're going to take this information that we have gotten from our graph, and we're going to write it. Y equals, our slope is -3 over 2. Keep the x, and it's +4 for the y-intercept, so +4. And that's our equation. Y equals -3 over 2x plus 4. And as you can see, this line is when we look left to right like we read and we encounter this line, we can see we're going downward. So that slope should be negative. That's another check for yourselves. So if you forget the directions on these numbers here for counting slope, remember when you're going to read left to right and you wind up going downwards, that is a decreasing line which has a negative slope. So just put a negative sign in front of your slope. All right, let's try another one. All right, again, yours will always have arrows on them, okay? All right, so we're looking at this and we're saying, all right, we need our y-intercept. That's the first thing we should always grab. And as we can see, our line comes through and it hits our y-axis right here. It also hits our x-axis at the same time. But that's kind of irrelevant for our equation, so don't be fooled by that. So our b value, our y-intercept value is 0, crosses the y-axis at 0. So now we need another value, point actually here so we can count. So we're looking for grid lines, all right? We're crossing the grid lines. It doesn't cross there, it's too close there. So it's really at the arrow marks, okay? So that's why I want you to extend your arrows a little bit longer. All right, so your line should be longer with your arrows off the point, but let's use that. We could have also used this one up here. So let's walk from our red line, from our red point down to our pink point. So we're going to go 1, 2, 3, 4, 5, and we went in a downward direction, so -5. Now we're going to go to the right, 1, 2, 3, in that direction, and it's positive. So our slope is a -5/3. And as you can see, our line, as we read left to right, when we encounter the line, it goes downward, so it is a negative slope. Slope-intercept form again is y equals mx plus b. We're going to plug in our m and our b. So I'm going to write this out here. So y equals -5/3 x plus 0. Now we don't keep plus 0 in any equation. We're a lot, more grown up than that. We ditched that around 3rd grade. So we're going to rewrite it and just say y equals -5/3 x. And that is our slope-intercept equation for this graph. All right, next one. Take a look at it, and let's see if you can figure out what type of slope we're going to have. And as you can see, we're going left to right, and when we encounter the line, we'd be going up, so the slope should be positive. So that's our expectation when we do this. So we're looking to see first where our line is crossing our y-axis, and as you can see, it crosses right here at 2. So my slope, my y-intercept, is 2. Okay. Now we need a slope, so we're looking for another point that's on a grid line, and as we follow it down, they get a little easier because we have a little more line this way. I can see that it crosses the grid here. It also crosses here. So it's up to you what you want to do. But I'm going to walk from my pink point up to my red point. Okay, so this one. I'm going to go 1, 2, 3. And that's in a +3. And I'm going to walk over 1. That's a +1. So my slope is 3/1. So it's a rise over run. Or you can just simplify it to 3. All right, they're both positive. All right. So now we're going to write our slope-intercept equation. We have no signs on these, so that means that it is a both positive. So 3x, and that's a +2, so put +2. And that is our slope-intercept equation for this line. And as you expected, because your line was increasing, your slope is positive. All right, 2 more to go, and these are our different, unusual cases. Okay, first thing again we want to do is we want to put arrows on the end of our line, okay? Make sure we always do that. We need our y-intercept. So we follow our line as we go left to right, and as we can see, it's not going up, so it's not increasing, and it's not going down, so it's not decreasing. So our slope is not positive, and it's not negative. So it's got to be one of two things, either 0 or undefined. So as we follow along and we find our y-intercept, our line crosses right here, and it's at -1 on our y-axis. So our slope, y-intercept, which is b, is a -1. Now we need a slope. Choose any other point on the line that crosses a grid, and any one of these will do. I'm just going to go out here to 3, okay? 1, 2, 3 away, just so I can, have a little room for counting. I'm going to walk from my pink point to my red point. But first I have to rise, because remember, slope is rise over run. That's our slope. And when I try to go up or down off this line, you can see that I can't because I'm still on that line in this horizontal position. So I can't go up or down, so that's a 0 move. So my rise is 0. But I can walk 1, 2, 3 all the way to the left, which is a -3. And 0 divided by any number, no matter what it is 0. So our slope is 0. Another way you could remember this is, as we've studied, is that horizontal lines have a 0 slope. Okay, because you can tell right away it's not increasing and it's not decreasing. So when it's horizontal, just like your floor, if you walk across the floor of a classroom, your house, outside, for the most part, everything's kind of even sloped. You won't fall off it. It's not too much effort to walk up it or walk down it. It's not ramped. So therefore, it's a neutral slope or a zero slope, okay? So when we write our slope-intercept equation, our y is still there, our equal stays there, our slope is 0, our x stays, and then our y-intercept is -1, so -1. 0 times x is just 0, it wipes out. So y equals -1. And again, if you remember from what we've studied already about vertical and horizontal lines, y equals a number, the x is missing, is a horizontal line, its slope is 0. And lastly, we have a line that is vertical. Okay, I'm going to make that a little darker for you to see. We need our y-intercept, and we're looking for a y-intercept. And does this line that is vertical ever cross our y-axis, which is right here? And the answer is no, it doesn't. It's kind of parallel to it, right? So it never crosses that y-axis. So therefore, we don't have a y-intercept. So we're just going to write none. We don't have one. And if you remember, our slope for vertical lines is undefined. Okay? And if you don't remember, then we pick a point. Any 2 points on the line. We don't have a y-intercept, so just pick any 2 points, and I'm going to space them out. All right, so first we rise, then we run. So we're going to go 1, 2, 3, 4, 5, 6. So we went upwards in 6, so it's positive. Then we try to move left or right. Okay, and we can't move left or right, so it's a 0 to go left or right. I'm just going to put a double arrow, it's 0. So remember, our slope is rise over run. We rose 6, we run 0. We can't divide by 0, so therefore it's an undefined slope. And everywhere on this, where you look, you're always going 3 to the right, and you're staying at 0, you're going 3 to the right, you're going up to 3, you go 3 to the right, you're going down to -4. So what you notice is that your x is always 3. So in this case, we don't have the slope-intercept equation that we would typically have as y equals mx plus b. So memorization of vertical and horizontal lines is usually best to identify them for their slope and for the type of equation that they are. Okay, so vertical lines are always an x equals a number, wherever that number is on the x-axis. And in comparison, our horizontal lines are always y equals a number, wherever that is on the y-axis. Anything that slants, increasing, or decreasing, you will have a slope and a y-intercept, even if the y-intercept is 0. And that is how you write equations of lines that are graphed.